Anyway, I'm Dustin McNeely with Columbia Hydronics. We are the manufacturer's rep for the locking bar boilers and also the B&G pumps and whatnot. But so I guess we're here today to kind of go over our product and whatnot. So I'll just go over things that I know and kind of things to look at in the sense of maintenance, things to look at if there's any troubles or things like that, and then I'll let Sheldon take over and he'll go over kind of controls and features of the boiler and whatnot. So he'll go pretty fast. So anyway, these are the locking bar boilers, and these are 3 millions, so the 3 million BTUs. Basically, what we need to look at here is this, on the back side of the boiler, the main thing is basically our neutralizer, the condensate neutralizer. Basically it comes down through the venting, comes back, and then it goes to a neutralizer that has pellets in it that neutralizes the water. That's something that needs to probably be looked at about every 6 months to a year. You think, Sheldon, about that? So about every 6 months to a year that needs to be looked at or tested. Usually we use little paper strip testers for pH levels, and that's basically what you want to look at, and it'll tell you if your media is either being broke down and gone or whatnot. Also, you want to make sure when these things are running and condensing that you do have flow through that, because if it doesn't flow, then it starts to clog, and then you'll clog and then back up into the vent, and then you might get some fault codes in the sense of flue vent and everything else. So that's that. Other than that, how are these controlled? I don't see any isolation. Oh, okay, so valves. So you guys are shutting off valves and basically on boilers coming on, so these valves. And then there's a position switch on these valves that shows open, closed, and whatnot. So the one that's open should be the fired boiler. Other than that, the other one should be closed. Because you don't want to flow through the boiler on an off boiler. It's just the way, good practice. Also, we look at their relief valves, in the sense of leaking or anything like that. They could be hung up, stuck, or like I said, need to be replaced. Other than that, there is on the front side of that, we can go to the front side, and then I'll let Sheldon take over, and there's a filter on here that we need to look at about every 6 months to a year, just as well as the neutralizer. So, okay.
Your automatic valves,
okay,
shut so that water only goes through the one working. If you have a power failure, do they fail closed? We've had that happen at one of our new buildings. They all stayed closed and the pump stayed running, and they were all sitting there blowing their relief valves, scared the hell out of everybody.
Okay.
Evacuated the building, think it was a bomb was going.
Oh, wow.
Are we going to have that problem here?
That's a school in Northeast Portland?
Yeah.
I can't remember what
Bobby.
Yeah.
Okay, so what happened in that case, since we're kind of going off from that, is that you have 2 boilers. One actually was turned off, and something happened. So how these valves work is, as Dustin mentioned, the last boiler fired keeps its valve open. So if you look at this one, the window's yellow. So water's flowing through this boiler now, okay? When there's a demand for heat, we okay?
Yes.
The boilers will look at it and say, okay, which one do we want to fire? If it's this one will open and this one will close.
Proceed calmly to the nearest
So,
exit and leave the building
these
immediately.
valves are
Do
power
not use
open,
the elevators,
power closed.
use stairwells
So if
where
you kill
necessary.
power, the
All
valves won't do
handicap
anything, they'll
occupants-
stay right where they're at.
So one will always be open.
One will always be open on this line of boilers.
Okay, that should take care of it.
If there is a problem, and we kind of went over that previously at the school, if you have an issue with a boiler and it's in fault, leave it in fault, don't kill the power, leave them on. That way, these boilers are all communicating with each other. It knows it's in fault. If you turn it off, it doesn't know.
What if you have a problem that needs to be locked out?
If it needs to be locked out, there's another means you can do that. There's another option that we later on, if you want to add, you can have what's called an alternate leader. Right now, the boilers have a specific leader. Which is boiler number 1? Is it that one or this one?
I don't know.
Whichever the leader is. Okay, yeah, this is boiler 1. So everything's been programmed to boiler 1 to tell 2 and 3 what to do. If you need to take boiler 1 down, for instance, then there's an option called an alternate leader. You can actually replace the main header sensor. And once you kill power, you kill communication, the alternate leader will take control of the first and the second and the third boiler. Okay, that's something we can add later. It's not that much more money. The sensor is, I don't know, $150 plus a little bit of labor, a little bit of program. We can throw the programming in. But if 2 or 3 is out and you do turn it off, as long as the master's on, we're okay. It'll realize that boiler number 2 is gone. It can't see it no more. It can only see boiler number 3. So you only have the capacity of the 2.
So are you saying that we never should lock that down, and if we do, what should we do to avoid that problem?
If, for instance, you have to lock it down, you could put these 2 in a manual mode, and we can go over that if you guys see fit. Right now, the energy management control is sending a what we call a reset signal, an outdoor reset, based on outside air temperature. It's adjusting its internal temperature because the colder it is, the more energy is needed in the system, right? So the energy management will rise that set point. As the warmer it gets, it'll lower that set point, basically for efficiency factors. We can put a boiler in the manual mode and it'll just operate at a fixed set point, be it 160, 140, what have you. That's possible. We can go over that. If, for instance, it comes to a maintenance or it happens that you have to operate the boiler without that one, give us a call. We can walk you through it.
So we should probably put a label on it, never turn it off.
Correct. Even though if it's in fault, leave it on.
Yeah.
Just leave it on, and that way, because it's the master, it won't be able to provide you heat. It's in the safety fault. However, it'll still command the other 2 what to do based on that temperature sensor that's in the main. There's a main sensor in the supply to the system. This boiler's reading it, and based on that temperature, it's making decisions off of that. And like, remember what I said about an alternate leader, we can program it, put in a different sensor that has 2 elements that will read, this boiler will read it, and this one. Only when it loses that one will this one take control over it. So and there's varying degrees of control that can be had.
That is set up that way?
It is not.
No.
You're
It is
going to
not.
do it though?
That is an option that can be had. The sensor is about a $150 sensor, a little bit of labor, we can push some buttons, help you folks do that. If the school district wants to entertain that, we can. So we've been we haven't been seeing it in the specifications because primarily Lochinvar is the only one that can do that we know of.
So what happens if you shut this one down the way it is for repairs?
This one?
Yeah, then you got to switch the other to a manual, huh?
Correct, yes.
Yep.
There's a little bit of push button that has to happen. So.
And we're going to want to go over that too. What you do your guys' spill, but
Yeah.
let's talk about that a little later.
Yeah.
Okay.
Okay. So let's go to the front and show where the air filter is and stuff. It's very important. Yeah, let's do it on this one. Yeah. You got it. He's got the filters on?
Yeah, this one doesn't have it.
No.
It's a direct.
Oh yeah, that's a direct feed.
Maybe down here. There's a
No.
filter box.
No.
It's a weird filter box.
Okay.
Oh, we can open it.
Yeah.
Oh, this is an old 2-valve one.
Yeah.
It's been in a while.
Yeah. Wrenches. Okay, these actually don't have the filter on them. I didn't know if they did or not. Usually there's if you have them with them, there's like a slide-in filter, but they're not. These are not equipped with them. So
Where's this hit? It's here.
Huh?
Where's the air coming out?
Right here. It's coming in, and then we're coming out.
So it's just being drawn from the other
It's right
end of the room.
over.
Yeah, from-
Over there, stubbed out.
Is that just stubbed out and it's not going? Okay, so it's take room air. So it's just pulling.
There's a grader, but the drills are half plugged up, so.
Oh, okay. So it's not connected yet. Okay.
If they're going to, it looks to me like it's just.
No, they can take room air. They could have done it. I mean, yeah. I mean, if you're pulling room air, it could have pulled right here, but.
Just stubbed over by the grill.
Yeah. Okay. So anyway, so that's why it's going. But I'll let Sheldon take over in the sense of controls because there's really not too much in the sense of this. The only well, here's your high limit control in the sense of safety. That could be dialed in. Usually we set them about 195, and that's what the high limit is on set at. That is adjustable. And then also on the front of the board, here's your main power, reset, and your test buttons. And then other than that, then that's the touch screen display. And then I'll let Sheldon go over that.
Let's get you set up with the mic real quick.
Okay. Because I think that will be more important, the controls.
Where is your pilot and flame sensor?
The pilot and flame sensor are actually inside. If you look, you can't really see it. It's way in the back and the top. So this black portion back here that looks like a 55-gallon drum is your heat exchanger. Your flame sensor and igniter are sitting up on top.
On top of this?
No. So you can see the air manifold. So these aluminum things are your blowers.
Yep.
So you're probably shining light right at it. If you're right on the top of that cylindrical device is the heat. That's the heat exchanger. That's where you'll find your igniter. Yeah, it's on top. Screen that we have here. This one's one of the member boilers, so you may not see all the information, but it gives you various temperatures, the flame signals, what have you, that's going on. You can actually, if you want to, you can step through it, and it'll give you some fan speeds. It gives you some idea of what actually is going on. Something that you may, what happens if you get into setup, that's where you actually need a passcode to get in there. And I know we gave that to the school district. No, not quite. Anyway, so you can, what else we got here? So you can see some history of the faults and what have you, and you can actually view them if you wanted to. But so there's some information that's limited on the member boiler. So if I hit the cascade, it's not giving me any information because it's a member boiler. If we open that one up, we would see the other two boilers. It'll tell us there's two more boilers attached to it. Kind of using this one because it's the closest for everyone to see. You guys have any questions or any?
Yeah, where's the igniter at on here? Oh, I see. Here's the transfer over here.
It's actually will be sitting on top. I'll get you a photo. So the drum, I'm sorry, it's up here.
Right there? Okay.
Yeah, so we'll
That's that red deal,
yeah,
that's
so what we'll do is we'll get the manual. We have a manual here. I'll get that for you. Okay.
That's the heat exchanger back there.
Yeah. So yeah, you see the big.
Okay.
Oh,
Whose idea was this?
excuse me. What's the rotation?
What you're trying not to trip over as you're walking back and forth there.
I can answer that. So, yeah. What else can we tell you about the controls?
If they have to go on manual like a reset
Yeah.
or trying to put in
We-
their own temperature.
Yeah, that gets a little bit deeper. We can go with that. So, with the district on that. So I don't know if there's any other questions you guys have. What to maintain? If there's it.
Filters in here?
Excuse me?
Are you going to put filters in?
No, these ones do not have the capability to put filters on there.
So this is your main air intake right here, right?
This is your air intake, this flexible hose right here.
Yeah, but what's this here? This vent on the back side here.
What are you looking at here?
There's this must suck in there. Here's
Yeah, that's your blower. So it's drawing air in this way, pushing it to that manifold and into the top. So you actually have two blowers. So the reason is that you have two different blowers is you have one's much smaller than the other. And so when you're on the lower end of the turn down, you have higher turn down because of that. Most people put equal sized blowers, but with one smaller blower, you can have a much lower turn down than others. So that's where you have two blowers.
This looks like it. Plug up pretty easy right here.
So the air actually comes into this box and mixes in here. This is just a vent for the motor. It's drawing air into this way, and your gas is introduced here, and it mixes and it goes into the top.
Okay, so that's the igniter right back there, right?
That on the side there, I think that may be your low water cutoff. Your igniter and stuff is sitting up on top. I'll get you the manual that shows the exploded view.
Is there a surge suppression?
No.
Well, all these electronics, if we have a power outage and you get spikes and stuff like that, are these going to protect against that?
They don't have any internal. That would actually have to be external.
Yeah.
Just like you would in your house. Yeah, I don't know. Do you have anything in your house to do? You can put stuff to protect the whole house.
Yeah.
So, but no, they do not have their own internal surge protection.
Are the panels surge suppression?
There is no surge suppression.
Okay. Are these the same boilers as Fabio?
Yes, there's the same model. They may be a different generation, could be. Just by looking at it, I assume these have been here quite a while, at least 1 to 2 years. So the design have changed a little bit. Front-wise, you won't see the difference. Control-wise, you won't see the difference. But inside there's a little bit of difference in there. During maintenance, you always want, when you need parts, you always want to ensure you provide the serial number to the boiler. And that tells us what parts to get.
The serial number's on the back side
Yeah.
of this boiler on this tag. Just so you know, it's right there. And if you have that, that will tell us how it's built, all the component parts that are on the unit.
So as for maintaining and keeping these boilers operating, that should be about it. Lochinvar offers more in-depth classes for maintenance and what have you back at their facility in Tennessee. I think, if I'm not mistaken, if we have enough folks, they can actually bring the class out to us. But I don't know, does anyone have any questions on maintenance and what to look for?
No filter. Is there anything we need to be concerned about inside or
You know, as long as the room's fairly clean, I would say no. There is a procedure once a year to open up the boiler and clean the actual burner itself, if that becomes a problem. So, but it's a fairly in-depth procedure to open it all up if you need to. But yeah, typically as long as the room's clean, then really there's not. Future models actually have a replaceable filter. Like I said, this one's probably been sitting here at least 2 years. I'm thinking, yeah, 1.5 years, 2 years, because just by looking at it and seeing what's inside, this is they constantly are making changes. That's why it's very, very important to keep the serial number when you order parts.
the warranty's up already?
Excuse me?
The warranty's up then?
Warranty is, well, the factory warranty may be up because it's I can't remember how they refer to it, but Columbia Hydronics will warranty from the day of startup for, I think it's a year or whatever the specifications calls in this case. But
Side panels come off here?
yes, you should be able to, not very easily, but yeah, they do. Does anyone have any other questions on how to maintain these guys before we start ripping off boiler skins and getting in deeper? Not after initial operation. You generally do not have to flush them once they're up and running, once they've been cleaned, the initial. They're stainless steel, so it's not like an old school boiler where there's oil inside there that got put in where you have to mix it with TSP to boil it all out and what have you. So that's not an issue. So, but yeah, your chemical treatment guys probably would have been fine with it. There's nothing to. I'm sure the chemical treatment guys filled some chemicals in there, ran the pumps, drained it, and filled it back up again, and that should be perfectly fine. So.
Yeah, it looks like these things were left.
Yeah.
Not exactly like
We pass this back to you one more time.
So these use what they call a negative regulation design. This valve is measuring this air pressure. So what happens is the controls the speed of the fan. So as the fan speeds up, it draws a higher negative pressure. This valve opens more and more. So that's how it controls the throttling of the valve.
Two separate valves, I see. So the blue one's one, this one's the other. All right. So, would the E-stops being pressed over at Fabian have made a difference with the temperature pressure valves going off?
What was that again now?
Over at Fabian's, those boilers?
What?
Using the E-stop switch at the wall, could they have hit those and that would have stopped the boilers from operating with the water coming out of the temperature pressure valve?
No, because what you have at Fabian is you have your system pumps in front of the boilers.
Okay.
So typically people put the system pumps after the boilers. So it's pushing water away from the boilers into the building.
It's a negative draw away. So,
correct. So if you did anything to shut the boilers down, that wouldn't have stopped those pumps from running. What's happened? The reason why you're lifting the relief valves has nothing to do with the boilers.
It was the pumps.
The pumps are pushing into the boilers. There was deadheading the system. So the only way to stop that would be to kill the pumps.
Okay. So it was pushing water out.
Pushing water into the boiler.
Into the boiler.
Yeah, and those two valves are closed because someone had put one off and turned the other one completely off. So again, you want them to keep them on. So this is it. Yeah.
So if they had set those pumps up to go off on the off switch of the boilers and interlock it with the boilers.
But no one would do that because that's not a code.
Yeah.
Typically what you do is you put the pumps after the boilers. The pumps are looking at your differential pressure switch, differential pressure transmitter in the system. Okay? So if you put a valve in between the pump and that sensor, it can't sense that. So it's going to go wide open. The sensors are going to go zero. There's no differential, so it's going to try and pump. It's going to go wide open, pushing out against the boiler. So if you had the pumps, boiler, the pumps, and your sensor, and who cares what the boilers did, as long as the pumps can see its sensor, it knows what to do. The pumps and the boilers are not interlocked in most control, in 99.9% of the application. They can be, but they're not. So yeah, it wasn't the boiler's fault. The boiler was only showing the symptom of the valves lifting. It had nothing to do with over temp, over pressure, or the boilers themselves. They were not in a problem. Yeah, there was no humidity hazard. There was not a problem with the boilers. Why the valve lifted? Because it was doing its job. Because the system was overpressured and it had to relieve the pressure.
Thank you for that explanation.
Okay.
That was a great explanation.
Operator error. Yeah.
And a solution for it.
So we just want to record how to put the boilers in the. Okay. Okay. So this is the master boiler. In order to put the boiler in the manual mode, basically you have to make this one not the master, take the master out of line. By doing that, you have to get into the setup. So what BMS stands for Building Management System. That means the energy management guy has control over it. We have to deactivate him. He's not taking control over the boiler anymore. You actually have to go into the cascade position and we can leave this one out, and then what we can do is you can go to this one and turn it in the boiler number 1. So we have to go over to that one. Basically, you have to also apply the changes. Once you make the change, what I told this boiler is that don't pay attention to the energy management anymore. And then what we're going to do is go to this boiler and tell it it's number 1 now. And with this boiler off, now it'll control. The bad thing is it'll only control off of its outlet temp sensor, not the system sensor. So that's the beauty of adding the special dual element sensor to do the what we call the alternate leader. You wouldn't have to do this function. So, but I'm not going to apply it. You could apply the changes, and whatever changes I made, it would go up into it. I'm just getting back out of it.
That's what you're doing just to put this in manual.
Yes, so it's a little bit drawn out.
It's just taking it offline and starting this one up. Then, is this one on the building management then?
No, it'll only bounce off of its limits.
That's the only one that's controlled.
Correct. Again, if you wanted to, if the school district wanted to, $150 sensor, a little bit of work and programming, you wouldn't have to do all this function.
So by going through that, that'll tell you all 3 boilers are on and 1's drawn.
Yeah.
But that's the only one that communicates with the computer.
Yes. So if you went to view Cascade, so go to that one and say view, very top bar. It'll be 0, and then go to, on the left hand side it says Cascade, hit the Cascade button. Left hand side, yours says 0, nothing. This one shows the other 2 boilers. So yeah, so it shows leader boiler, boiler 1, boiler 2. So in essence, we'll go over to this one. It says boiler 1, and then we can. So what you would do is go to setup.
But then the way it's set up, that one shows what it'll do.
We change this on the 0, and Cascade status, and then it'll be number 1. And then you should be able to do everything. Then this one will start operating on its own, because we already have had so it'll work off of these temperatures. Its set point will be now 150. That's what it'll target. So it'll just, seeing as how we don't have full control over it, it's only measuring the outlet temperature sensor. It's going to just bounce off of that temperature. It'll short cycle like crazy if the weather's moderate. If it's cold, maybe you may have a cold call or what have you, but you'll still provide some sort of heat to the building. Again, I think it pays dividends to add that $150 sensor, a little bit of program. We'll come down here, and if the school district wants to do that, we'd be more than happy to come down here and program it and work with them. All you got to do is swap the sensor out, run another wire to this guy, and I'll come down and do some programming, and then you could be happy. That one you could take completely down, and this one would realize that one's dead, and you'll have the heat of this one and that one. If this one needs to go down, that one will recognize this one's down, it doesn't care. You will have the heat from this one and that one. So I think it'll probably be much easier and much better on the service tech if we do that, and we can explain it. We can look at videos, but this is going to happen 3 o'clock in the morning.
Have an option to go
Yeah.
one or the other. And this one will still
Correct.
be like.
But if you don't apply that alternate leader option and you want to do it manually, obviously it's going to be 3 in the morning, and you're going to get a guy up, and he's going to say he's not going to have that document in front of him. I mean, it would be seamless. The energy management controls are looking at these boilers, I assume, and they could tell whether the leader's at fault or not, I assume. So yeah, so that would probably be best.
We good?
Are these the same ones that Fabian has?
Yeah, they're the same.
It's a little bigger than the ones
They range from 750,000 BTUs to all the way up to 6 million. So they just scale up.
but as far as
As far as the touchscreen, everything, functionality, exactly the same. Internally, may have some different components. Locking bar does the good and the bad part is they're constantly evolving. Bad part is it's hard to know what you got to make sure you got the right thing. So that's why some of them again are very, very important.